go ahead and kick it off. So thanks everyone for joining us for our webinar today, using AI to auto-detect and remediate incidents. Today, we'll be sharing how you can use intelligent automation to rapidly detect and recover from incidents. So before we kick off, here are a few quick housekeeping items. We highly encourage any questions from all of the audience. So feel free to pop those in the Q&A window, and we will answer them in our live Q&A section at the end of this presentation. And after the webinar, we'll also be sharing this recording with all of you. So feel free to share those with your respective teams. So let's kick it off with a quick round of introductions. I'm Ancy, Director of Product Marketing at Blameless, and excited to share how SRE best practices and automation can really help DevOps teams spend more time on the things that matter. And I'll hand it off to Gavin and Paul to quickly introduce themselves as well.
Hi, my name is Gavin Cohen. I'm responsible for product at Zebrium, and I'm also one of the very early employees at Zebrium.
Hi everyone, this is Paul Chu, Senior Sales Engineer for Blameless, and I'll be taking you through the Blameless demo for today's webinar.
Fantastic. So here's a quick intro into our agenda for today. So we'll kick it off first with some context on how demands for innovation and reliability are really unprecedented in today's digital world. We'll then dive into solutions around autonomous incident detection as well as automated incident resolution to help teams meet these demands. Gavin and Paul will share a quick live demo of how the Zebrium and Blameless solutions help you operationalize best practices around incident detection, triage, and response. And at the end, we'll leave some time for all of you to ask some questions. So as you all know, digital leaders like the FANG are now really setting new benchmarks for reliability and performance. And the survival of the fittest is now pegged not only to software innovation velocity, but also to the reliability of digital experiences. But as you all know, there's also a simultaneous explosion of systems complexity to really support these new demands around innovation as well as reliability. And there's so much more data that's now being generated across systems. And what this means is that the universe of unknown unknowns is becoming more and more vast with the exponential growth of potential failure modes given the complexity of distributed systems. And so what that means is that there's way too much data that then can be manually triaged by humans. We hear that 58% of DevOps professionals rely on 5 or more observability tools, which means that failures can lead to cascades of thousands of simultaneous alerts. Responding to those alerts also is extremely complex and often requires many manual tasks that are really, really stressful in high stakes scenarios. And this includes things like mobilizing the right team, establishing roles and responsibilities, executing runbooks, updating stakeholders and executives, and much more. And so for DevOps professionals, finding the signal across the noise, let alone taking the right action during critical situations, is deeply stressful, manual, and painful. And the entire process relies too much on brute force, with tribal knowledge often siloed across certain individuals and teams. And so what this means is that there's significant negative business consequences, such as wasted engineering efforts, difficulties in retention and stress on the team, as well as negative and subpar customer experiences. And today's solutions aren't enough. So this is a view into the current incident lifecycle across, the typical stages of detection, management, and learning. We see that in the incident detection stage across, dozens of observability tools, there's typically siloed and passive and fragmented because teams are using so many different solutions, highly index-driven, and oftentimes it's being driven by manual event and alert rules that can quickly go stale. This feeds into your incident management stage, where typically many tools will have, companies will have tools around alerting, response mobilization. They most likely will use some kind of chat ops or workflow solution to mobilize teams. But today's solutions also, result in a lot of siloed information. And because of the breadth of tasks that needs to happen during a critical incident, there's significant cognitive overhead in trying to figure out all of the things that need to happen instantaneously. And finally, at the learning stage, which arguably is the most important stage because it's what allows you to get better and better over time, This is often also an afterthought because teams are constantly reacting to things that need to happen instantaneously. So in the postmortem phase, operational reviews, we see that oftentimes it's difficult to adhere to SLAs and really establish accountability around doing the follow-up action items that emerge from postmortems. And postmortems themselves are often a pain, with teams needing to dig through siloed pieces of information for hours to really draft up a narrative. And so this goal of continuous learning and having a feedback loop around the incident lifecycle so teams can focus on doing less things that are repetitive, oftentimes is incredibly hard to achieve because, data is lost at each stage of this lifecycle. And so in such a context where manual toil is commonplace but no longer sustainable given unprecedented system complexity, teams really need a solution that allows for intelligent automation across the incident lifecycle. And that's where Zebrium and Blameless comes in. So Zebrium is a powerful solution that drives autonomous incident detection, and together with Blameless, which facilitates intelligent action and learning, teams can spend less time on manual toil during critical incidents and significantly reduce impact to the business. So I'll hand it over to Gavin now to discuss how teams can rapidly reduce MTTA and MTTR through autonomous incident detection.
Thanks, Ansi. Ansi just mentioned the term autonomous incident detection. The idea of autonomous incident detection is to use machine learning to automatically detect incidents and their root cause in the first place without any work at all from humans. Before I explain how that works, let's look at how most people detect and troubleshoot incidents today. Typically, there's one or more log management, monitoring, or even observability tools that are in place. And the whole process today is entirely human-driven. So we have humans who set up agents and build parsers to extract any information that they wish to process. Then we get a team of experts who go and build alert rules to detect known symptoms. Now, when an incident actually occurs, you're either detected, hopefully because one of your alert rules triggered, but in some cases you're actually notified of that incident only because a customer calls in or because someone notices a service is down. So now that you notice there's an incident, we then switch to a phase where humans assemble, and it's typically all hands on deck where people search through logs and look at charts and metrics and try and uncover what the root cause was. And once that's been found, there's a resolution stage. And finally, all the learnings from that get built back into the monitoring systems. So you might tweak your dashboards, build new alerts. And this process is ongoing because every time software changes or anything changes, you have to go in and ensure that those fragile alert rules continue to work. So as I said, this is entirely human driven. There's a huge productivity drain, and not just the fact that there's a big drain, but it's often the most critical people in the organization that get tied up when one of these incidents occurs. When you don't get the alert rules correct, you suffer from alert fatigue. So we hear this all the time. You get over alerted and you don't know what's real and what isn't, and that involves extra work. And from a customer perspective and from a service perspective, there's often a very slow mean time to resolve where people actually wait while systems are down. So what's the way ahead? If we go to the next slide, please. So there's complexity in today's environments. There are stringent uptime requirements, but the number of possible failure modes in software today, particularly when you think about distributed applications and microservices and containers, the complex modes are very, very large numbers. And we fundamentally believe that this human-driven process that I just described simply won't and doesn't scale. So the bigger we get, the more complex we get, the more ways that software can fail, the harder it is to do monitoring manually. So if we move to the next slide, I'll talk about the way ahead. And it's really entirely machine learning driven, and we call it autonomous monitoring. And the idea here is it starts with this idea of a zero config setup. So essentially, you have agents that collect the logs and metrics, but do little else And there is absolutely zero config in terms of building rules or deciding what you want to do with all this data. So it comes into the machine learning system. The machine learning system learns patterns. It then uncovers automatically when things go wrong. And when they do, you get alerted automatically. No one builds those alert rules anymore. And from those incidents, they're very rich and descriptive incidents. They tell you what caused it. So they give you a very strong indication of root cause, and that massively resolves the time it takes to perform the troubleshooting and ultimately resolve the incident. So where we went from an entirely human-driven approach, we now have an approach that's driven by machine learning without all the human effort involved. And those manual alert, fragile alert rules that I talked about earlier become smart machine learning driven alert rules. And the net effect for everyone is more reliable detection and much faster mean time to resolve. So let me go through a few details on the next slide about how the process works. So as I mentioned, it's machine learning driven, and we actually use multiple layers of machine learning to get very accurate incident detection. So it starts with taking raw log streams, and we're just adding metrics into this as well, which gives you an even richer feed of data and better ability to auto-generate incidents. So you have this stream of raw events coming in, and then the first layer of machine learning kicks in. And this layer learns the structure of every single event and how to parse it and how to extract all the information inside those events. But more importantly, it learns how to categorize every single unique type of event. And this is really important because then the next layer of machine learning, which sits on top of that, takes that structured dictionary of events and it learns the patterns for each kind of event. It learns each event when it starts, when it stops, its frequency, its periodicity, and so on. And what that lets us do then is learn when you have anomalous patterns, when events break pattern, and those are then flagged as anomalous events. But that's not good enough. That's still a noisy signal because often you have events that just randomly occur that you wouldn't expect or occur out of sequence or out of pattern. That's not a good enough signal to say that there's an incident. So the third layer of machine learning then looks for very tightly correlated sets of anomalous event patterns. And when it sees that, we go from something that might be random to something where there's very high confidence that a real incident has taken place. And we know what types of correlated patterns to look for. So what this does then is auto-generates an incident, and it looks at the leading edge of that incident, and those events become the root cause. And you'll see this in the demo in a moment, but it's really, really good at identifying exactly what happened that led to this anomalous set of correlated events that ultimately make up the incident. So we raise an alert, and then you can take a look at what happened. So let me, or Fancy, if you stop sharing, I'm going to share my desktop, and we'll go through from there what it actually looks like from the Zebrium side. So I'm going to start in the Slack side, and this is actually a Slack channel inside the Blameless Slack instance. And we've set that up so Zebrium alerts inside there. So what you're seeing here is a 100% machine learning generated incident, okay? No human built this alert. There was no pre-configuration. The machine learning essentially picked up a root cause. In this case, it's saying Postgres stopped. It's picking up a bunch of symptoms. So you can see some SQL errors from the applications. For example, this one saying that there's a connection error, SQL connection error. And this entire thing makes up the incident. Now, what we'll do from here is we'll go into the Zebrium tool to verify that this is a real incident and to look at some of the things you can do. And then we'll go back to the Blameless side to look at how you take this through the entire remediation process. So I'm going to click on incident details, and I'm taken into my web browser directly into that same incident, but this time from the Zebrium software side. So again, what you see is a root cause, and we can see these two events saying the Postgres stopped. And they occur in the syslog event stream, okay? And then the symptoms, which are all the things that happened beyond that. So Postgres stopped, and then over here, for example, you see a connection, a SQL connection error. And if we look at it, that's actually in the Jira application. So what we have here is an instance of Atlassian software running in a Kubernetes cluster on a Minikube host. And it's picked up this incident, Postgres stopped, and then the knock-on effect inside the application. So you'll see if we go through each event, which I won't do now, there are Jira events that indicate how Jira was impacted. There are Bitbucket and Confluence events as well that show you that whole knock-on effect of what happened here with this root cause. Now, this is usually enough, and I can vote on it and say this is a good incident and we're done. But what I'll do in this case is let's drill down a little bit further to get an idea of what's going on. So now I'm taken to our event viewer. And here we see that same list of events, but more like a log viewer version of those events. And you can see they come from the syslog stream, the Jira stream, some Bitbucket and Confluence messages. But this gives you, again, a good idea of what's going on. But I can look in much more detail. For example, if I take this event and I click peek, I'm taken into that log stream. So it's a bit like VIing that syslog that came directly from that particular host where the error occurred. And we can look at these two messages in context of everything else. When I'm done with that, I can go back to my filtered incidents, okay, which you see here. And now I can turn the filter off, in which case I can see all the log events from all the different components of the application, all in time series order interleaved here, that led up to the event. So you can see there are all these Confluence events here, then those syslog, then some Jira, then some other ones that weren't picked up as anomalous, then some more that make up the incident, and so on. Now, I won't go through all the steps here, but essentially, this is a full-blown log manager. You can see all the Kubernetes metadata next to each event. We can filter on things. We have structured tracks. We can do regular expression searches and so on. But this really gives you a sense of what's been going on. So in this case, it was pretty clear. We saw Postgres stopping, and then we saw the impact on the rest of the applications running in the cluster. So what I'll do is I'll verify that this was a real incident back to Blameless, and I'll hand over to Paul. So I'm going to take this entire session that we've been working on. We get a unique URL so someone can come back and look at what I just did. I can type in a message and say, this incident was caused by Postgres stopping, etc. And now I'll send it back to that same Slack channel. And from here, I'm going to stop sharing and I'll hand it back to Paul, who's going to take us through what the whole remediation process looks like from this autonomously generated incident on the Zebrium side.
Great, thank you, Gavin. So hopping onto the same Slack channel or the same Slack workspace, what that alert can do is basically trigger automatically the incident for us to mobilize and start collaborating to actually find the resolution to this incident. So in this case, what we've seen is that once the Zebrium alert was shared after some initial triaging by Gavin, we can then look at the actual incident and start inviting and mobilizing various users based off a variety of different parameters that we have configured within Blameless. So from here, just to kind of get into the main initial orchestration that we're doing, you'll see that the initial Slack channel will be created. We'll also have a conference bridge readily available as well for quick communication in some sort of video conferencing bridge. And then we'll also have an integration with Jira, where we'll actually create a ticket to then track all our follow-up action items resulting from this incident investigation. But as you see here, through that integration with Zebrium, we're then able to pull in the relevant details from that incident generated from Zebrium and have some context for the responders to understand what we're looking at and where to look first in terms of resolving this particular issue. So what you'll see here is that once you've mobilized the appropriate responders, that's based on how we configure Blameless as well as any sort of on-call scheduling that you're leveraging today, those types of users can be automatically invited into this particular Slack channel to start working on this particular incident. And what we'll see here is that with our Slackbot integration, we're then able to assist with automatically collecting any of the data findings that you're seeing as a result of your investigating of this incident, but also allow for quick tagging and also completing and also providing guidance around what tasks we need to complete as well. So we do have a notion of incident roles within Blameless to help easily delegate those different responsibilities out to the people who are involved with this incident, which you'll see here. So I've been assigned as the incident commander. I'm going to start running through this incident. We'll go and add some tags as we're going along. But really the idea is that we want to provide those guardrails to then quickly get everyone on the same page to get to that ultimate resolution of this incident. Another thing that you'll see here too is that as we're going through, we might want to create some JIRA tickets as well. So as we go through here, we're then able to identify any follow-up actions that we'd want to record and have generated to JIRA. We can go and have that quickly done just by running a / command that we have here to then have that ticket recorded. So you have it reflecting on the JIRA project side, but also as we go through this incident and we're reviewing what we've identified, how we resolve this incident within our postmortem tool, we can ultimately have these follow-up actions recorded within that final report as well. So as we're going through, the flow is that we'll be collaborating and quickly resolving whatever we can throughout this incident. But if we actually jump into the UI, in the background, what that Slackbot is doing is it's actually compiling those different data points and building them into an events timeline, which you'll see here on your screen. So we'll have various timestamps associated with those events, but also any screenshots that are added as we're kind of adding different pieces of artifacts to the incident, those will be automatically captured. Any links will be captured. And then any notable messages that will provide context in terms of telling that story of what happened in this incident can also be captured as well. So this is going to help you save time in terms of not having to manually create those timelines, but also being able to include this and having it as a reference point when you are building out your postmortem and discussing on how we can improve this particular process moving forward. Another thing you'll see here too is that there might be some sort of periodic communications that need to be sent out as well. So you'll see here that any communications that need to be generated from this incident can be sent out from Blameless. So in this case, I just have an update saying that we've restarted that cluster and the service should be back to normal. And we can go ahead and define whether this is an internal or external communication. And that way we can have this distributed out via email, sent via SMS, or even posted to a specific Slack channel. So in this case, I had it sent to a Slack channel. Once I actually sent this message, you'll have a timestamp associated with this. So again, just for clarification and granular reporting, we can include this within our final report as we wrap up the actual findings in the postmortem. So if I actually jump back into the Slack channel, you'll see that within our executive Slack channel here, we're able to send that update out. And that way you have all those updates informing any changes or findings that are notable to the critical stakeholders based off the severity and type of incident we're dealing with here. So after we've gone through the entire process, again, we've gone through the actual investigation, and ultimately you'll go through the various tasks, which will be recorded here. You'll have, a completion status at the very top in our summary bar, but ultimately we'll move this to resolve state. So once we've moved this to resolve state, what happens next? The next is that if we do have a postmortem required for this particular severity level, in which this is our highest severity level, and we want to always create a postmortem as a result of this incident, we can then hop into our postmortem tool. And there's two main areas that we'd like to focus on, at least from a usability standpoint. But the first section that we'll start with is the analysis page. So the analysis page is an area where we can come in and start leveraging this collaborative text editor to actively work on this document as we're kind of discussing what happened and how we ultimately quickly resolve this particular issue, identifying any gaps as well. So from here, as you see the activity happening, we can go and have different users adding their pieces here on the different sections, which can be preloaded into Blameless as a template, as well as leveraging our events timeline to then pull in those different pieces of information to ultimately provide that summary and that context of what happened for this particular incident. And then ultimately, once you've actually published it, it'll be sent out, queued up for sending out to different users via email, and that way they can automatically receive this report on completion. The other section is that if we look at the overview tab here, is we have a custom question section as well. So what we've heard a lot from customers is that there typically will be a series of questions that they'll go through. And then from there, they want to make sure that they capture all these different data points. But the reality is that these are, realistically captured in some sort of free form text approach. So by having these questions captured here within this section, we're keeping it very clean in terms of understanding what questions we need to answer, but also because we have this structured approach of capturing these questions, this becomes additional metadata for the incident, which you can ultimately report on. And we'll get into that in a second. But this is a great way to go and understand, who are impacted by the incident, what actually caught the incident. And if there's any gaps there, how do we improve that moving forward so that our monitoring does capture this particular instance. In this case, Zebra was able to capture this anomalous behavior, and we're able to quickly respond and actually get the service up and running again. And things like change. Change is also another common component of causing things to break or causing incidents. So also identifying that particular data element for this incident will give us some more context moving forward and saying, okay, maybe we need to do some more QA before we go through and actually pushing out that change. So this will give you some more context as a part of that lessons learned that we're extracting here. So once you've actually completed the postmortem, and there's a variety of different elements here, we can actually move this forward into different states. And as we do so, we do have a commenting section here, which can mention different users to then ping them via Slack and saying, hey, can you go ahead and review this and approve and actually push this through? Or, if you do reject it, you can then come in here and just start replying to this particular comment and have a threaded conversation here and saying, these are the reasons why I was rejected. These different sections need to be worked on. And that way you can kind of have more of an automated, streamlined approach in terms of getting this process through. So just to show you what it looks like is once I have that mentioned comment added to the postmortem, I'll then be pinged within that incident channel to then quickly be brought back into this particular exercise to make sure that we are able to kind of move this forward and ultimately get it published. And then once we do get it published, we'll then be able to archive that Slack channel. So that'll be off of your sidebar there, and then we can move forward to the next incident. So at this point, we published the incident, and now we want to take a look at kind of the overarching metrics that Blameless is able to capture. So if we go into our dashboards, which we call reliability insights, we do have a variety of different default dashboards for you to certainly leverage out of the box. But we'll go ahead and have some perspectives around incident overview, looking at breakdown by severity, by type, to help visualize any type of trends or one-off behaviors that we're seeing in whichever time frame you'd like. But we're also able to go ahead and look at different types of mean time types of metrics as well. So in this case, in this board, what we have is we have a rolling 30-day window of understanding what the mean time to identify, mean time to action, mean time to resolve are, to give us an understanding of the most recent activity that we're seeing. And then below that, we're able to then see the overarching mean time metrics there to give us some sort of comparison or baselining of how we're doing compared to the overarching metrics there. So this is a great way to go ahead and to get that visibility as quickly as possible. And certainly a metric that a lot of organizations, frankly, don't have access to based off of how we're tracking the incidents. Or it's just very manual and very time-taking to go ahead and pull those metrics out of. So you can also look at that type of metric here. And then more at a manager level or a director level, wanting to look at what postmortems are still out there that haven't been completed, which ones are outstanding and stale that need to be moved forward, and also which ones are in review that I need to go in and approve. So this is a great way to also have that type of kind of to-do view of understanding what are my responsibilities here in terms of moving this process forward. So this is a great way to go and understand that, and also being able to track those various action items as well, and the age of those various tickets. So with that being said, just to recap, we took a look at Zebrium, and Zebrium showed us how they were able to automatically identify, by leveraging machine learning, any anomalies that occur based off of the logs that it's ingesting. And by having those alerts generated from Zebrium, Gavin was then able to come in and triage to validate this is an actual incident, and then having it escalate into Blameless, in which Blameless was then able to orchestrate a lot of the components, the moving pieces around resolving this incident, ranging from mobilizing the right users, having the timeline built out to help kind of enable organizations to really coordinate the incident, but ultimately resolve it faster. And then from there, being able to extract those lessons learned. So with that, I'll pass it over back to Ansi, and we can go from there.
Awesome. Thanks so much, Paul. So to quickly sum it up, so Zebrium and Blameless really work better together by helping teams to really triage and detect and resolve and learn more cohesively across the incident lifecycle. So with autonomous detection and triage from Zebrium, as well as toil-free response and learning from Blameless, teams are able to really learn and improve so that they can continue to make their systems more resilient.
Thanks, Ansi. So on the Zebrium side, and you saw this in the demo, there are really two key things that we do. We automatically detect incidents, and that's with zero pre-setup, zero building of alerts, zero human involvement, entirely driven by machine learning. And then part of that machine learning incident automatically gives you an indication of root cause without you having to search through, gigabytes or huge volumes of metrics and logs. It just gives you that information right there as part of the incident.
Awesome. And Blameless is able to really augment observability solutions like Zebrium by bridging reactive and proactive worlds of work. And so it really starts with a service registry to build the right context around your services. So that includes hooking into observability solutions like Zebrium, but also in terms of other critical data like runbook information, workflows, and also other critical like CI/CD and pull request type information that track changes. And we're then able to automate tasks when incidents do take place through ChatOps-based workflows that minimize cognitive load during incidents. So teams can stay focused on rolling back or making sure that customers aren't impacted. This key information is collected during the incident and then standardized with the right context to minimize the toil of collecting and analyzing data. And so this is really crucial to accelerate learning and improvement. And the reliability insights into things like postmortem follow-up action items, SLAs, and the impact of incidents on different services and more are really crucial as well in establishing accountability that helps teams focus on improvement instead of continuing to react to things across their system. So with that, we're going to open it up at this point to Q&A. So feel free to enter your questions into the Q&A chat window, and we're looking forward to answering your questions. And in parallel, we highly encourage you to try Zebrium and try Blameless. So the links to those are included below. So at this point, looking forward to taking any questions from the audience. So we had one question come in. How does the Zebrium machine learning model work?
Thanks, Ansi. So yes, very good question. And I explained some of this earlier, but let me give you sort of a very high level perspective first. So imagine if you were a superhuman and you were watching every single log event from every single microservice all coming in and all your metrics coming in and you were watching them. What you would notice is that anytime there's an incident, and this works across really any kind of application, you would see a change of behavior across the logs. What you would see is maybe a rare event occurring that doesn't normally occur. You might see frequent events change their frequency. You might see that followed by some more rare events or events that maybe you've never even seen before. But you would see a very distinct pattern change. Problem is, humans are not good at this, but machine learning is. So what the machine learning really does is it learns the unique patterns for every single type of unique event. And then it looks for anomalous patterns, and it looks for tightly correlated clusters of these anomalous patterns across different components of your application or across different microservices. And when it sees that, that becomes the signal that an event has occurred. And when we look for anomalous patterns, everything's scored based on how unlikely it is for that event to break pattern. It's scored against its severity that we pick up from inside the event and a whole bunch of other things. What ends up happening is very accurate incident detection based around this that works completely unassisted or unsupervised with any kind of application.
Awesome. Thanks so much, Gavin. Another question, does blameless automatically follow up if someone doesn't complete a pre-described action?
Yeah, so that's another great question. So we do have reminders available within the platform so that whenever, and one example is that if you do have an SLA for completing your postmortems, the blameless bot will actually ping the postmortem owner or the incident commander daily. So every single day up until that SLA is breached, in which it'll then continuously allow for that ping to then be sent out on a daily basis. So, things like that will already have automatically configured. But as you know, we always take the feedback from our customers, and we're certainly improving that feature to then allow for them to customize kind of when and where they'd want these reminders to be in addition to the postmortem reminders.
Awesome. Thanks so much, Paul. Great. Well, at this point, we're not seeing any additional questions in the Q&A window. So if there are any additional questions that do come up after the fact, please feel free to reach out to either of our respective teams with the links that are included here on the screen. And with that, we do want to thank all of you so much for taking the time to join all of us today. And we look forward to seeing you next time.
Actually, Ansi, looks like just a question came through and it said, what is your workflow for contacting SREs out of normal work hours?
Yeah, I can take that one. So typically what we'll see is that there'll be some sort of paging tool being used at the organization. So, we do integrate with a couple of paging solutions out there where we can actually tie into that on-call schedule and actually have it configured so that it automatically pings and triggers that page. Or you can actually do a lookup within the incident channel to see who the on-call engineer is. And you can make a decision there on whether you just simply want to invite them into the channel or actually trigger that page to go off. So those are typically what we'll see. And then, certainly from a configuration standpoint, there are a couple other ways you could do that as well.
Fantastic. And we did see another question that came up as well. How much data is needed to train the Zebrium machine learning model?
Okay, great question once again. And that's actually something we get asked a lot. So most people expect that you need a lot of data, and it turns out you need surprisingly little. So just to get very real, and while we're speaking, I'm bringing up my web browser again in the background. That incident that I showed you earlier, which was detected across a cluster of Atlassian applications, the entire number of events that were ingested to be able to create that incident were 287,000, about 25 megs of logs, which is actually very little. It's actually a tiny amount. Prior to that, this system had seen nothing. So it had no rules built. It didn't know anything about the applications or how they characterized themselves. That entire domain, 287,000 events, was enough for it to learn the patterns and then trigger that incident. And it was literally that one incident inside that data set that it found. It didn't find other things. It found that one incident, which turned out to be really what actually happened. In practice, when you install the log collector, we typically see incidents that are accurate being generated after about an hour of seeing events. So the idea is you set this thing up, events come streaming in, and within about an hour, we know enough, or we have enough accuracy to produce good, valid events that are actually meaningful to you. So surprisingly small amount of data. Thanks for the question.
Awesome. Thank you so much, Gavin. So we also had one additional question that just came through. How do you send logs into Zebrium?
Yeah, actually, so I probably should have mentioned this with the previous one, but basically we use an open source FluentDB collector. We've made a few modifications to collect extra metadata, which helps with our correlation, but essentially it's a self-installing agent. So you deploy it in Kubernetes just with either 2 Helm commands or 2 kube control commands. From there, it discovers all the logs from all the different parts of your application and cluster, sends them through to us, and then we do everything from there. So there, again, 0 configuration. I've mentioned that a few times. A lot of people are sort of skeptical of this, but it literally takes less than 2 minutes to set the whole thing up and then get autonomous incident detection. You see the link on the screen, the sign up link. It's completely free to sign up and try, no credit card. It's really worth trying, and you'll see for yourself what it does.
We also got a question, is Zebrium limited to Kubernetes infra only?
Yeah, so we're not, is the quick answer. We have agents for Kubernetes, for Amazon CloudWatch, and for generic Linux, all based, or the Linux and the Kubernetes are based around FluentD, and the CloudWatch, we use our own mechanism. The software itself actually would work with anything. Just as a small company, Zebrium is, we've really decided to focus in these areas. And in particular, Kubernetes is just an ideal place for us because you have such rich events and rich metadata, and distributed apps are very hard to troubleshoot, but it absolutely works on any Linux system as well. And it's all part of the auto install, so all very simple.
Great. And another question, what are the components of setting up Blameless, and how long does it typically take?
Yeah, so Blameless is a SaaS product, so we have it hosted in either GCP or AWS. So there's no sort of upfront configuration or standing up of Blameless. And then the main thing that we would want to configure are the various integrations that we have. So Slack, of course, ticketing systems, any sort of paging solution you use, video conferencing bridge, which are, I would say, the most common integrations that we have, and those are all configured through the UI. So you just have to work with your admin or whoever has admin rights to those various tools in order to get the API keys, and then we'd be able to have those inputted into the actual integration configuration within Blameless. And everything is secure, so everything over SSL and all the security considerations there as well.
Great, thank you so much. Well, at this time, if you do have any additional questions, please let us know. Otherwise, feel free to ping us directly at the links listed below. And again, we wanted to thank all of you so much for taking the time with us today, and hope you all take care. See you next time. Thank you.
Thank you.